Hey guys, today we're going to be starting the last chapter of this school year, which is going to be all about similarity. Now, as we go through this chapter, you're going to find a lot of parallels between this and the work we did with congruent triangles, but really the work we're going to do with similarity is going to be focused on working with ratios and proportions. So let's talk about what we mean when we talk about similar figures. So similar figures are figures that are similar, and we use this symbol to mean similar, have the same size, or same shape, but not necessarily the same size. So same shape, but not necessarily the same size. So when it says to draw two triangles that are similar, I might take two equiangular triangles, but make one much larger. So they're both the same shape, they're both equiangular triangles, but they're different sizes. Now, two triangles that are not similar might be if I took a right triangle and my equiangular triangle. So they have to be the same shape. Okay. Now, two polygons are similar polygons if and only if their corresponding angles are congruent. So that's the first part. So corresponding angles are congruent and their corresponding side lengths are proportional. So if you think back to when we talked about congruence, we said to be congruent, all the angles had to be congruent and all the sides had to be congruent. Now we're saying the angles are congruent, but the side lengths are proportional. And really what that means to us is that the ratios of corresponding side lengths are the same. To be proportional, all those ratios have to be the same. So if I look at these two polygons, it's pretty clear to see here, because all my angles are marked, that all four of those angles are congruent. So we've kind of met the first criteria here for corresponding angles to be congruent. So now I would need to check the ratios of those side lengths. So for example, I know that side AB corresponds to EF. And so the ratio of those sides is 6 to 12. I know that side AD corresponds to EH. So the ratio of those side lengths is 5 to 10. And I could go all the way around. DC corresponds to HG. So I have 4 over 8. And then I would check CB to GF. So I'd compare 5.4 to 10.8. If I were to reduce those, I would notice that all of these ratios are equal to 1/2. Since all those ratios are the same, that tells me the side lengths are proportional, and I could then say that quadrilateral ABCD is similar, I would use my similarity symbol, is similar to EFGH. But again, we couldn't say that until we had checked that all four angles are congruent and all the corresponding sides are proportional. So for the last piece of this is some vocab, the similarity ratio. All the similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. So for example, if I had gone back up to this example, the ratio of the corresponding sides was 1/2. So this example would have had a similarity ratio of 1/2. Now we have to be a little careful about how the question is stated. In this example, we want to know the similarity ratio of triangle ABC to triangle DEF. So if I took a corresponding sides, I know that side AB is going to correspond to side DE. So the length of AB is 3. The length of side DE is 6, and we have a similarity ratio of 1/2. Again, just the ratio of the lengths of those sides. Now, if I were asked in this case the similarity ratio of triangle DEF to triangle ABC, now I'm comparing the length of DE, which is 6, to the length of AB, which is 3, and in that case, our similarity ratio would be 2. So just a slight difference in how that question is phrased. So let's go ahead and take a look at what we need to be able to do with all this. And we actually have 4 main goals for today. Okay, the first one is going to be to identify pairs of congruent angles and corresponding sides in 2 similar polygons. Again, we worked with this a lot when we were talking about congruent triangles. Second goal is to determine whether 2 polygons are similar. Then being able to calculate the similarity ratio and write a similarity statement. And then lastly, using the properties of similar polygons to solve for lengths in a figure. So that's our goals for today. Okay, so the first 2 here, we already know that these are going to be similar figures. So all we're asked to do is identify the pairs of congruent angles as well as the pairs of corresponding sides. So I'm just going to break it up. So my pairs of congruent angles, again, just like when we did congruent triangles, all we're looking for are the markings here and matching up the markings in one diagram to the markings in the other. So I know that angle A is congruent to angle E. I know that angle B is congruent to angle F. Angle C is congruent to angle G. They both have those double arcs. And I know angle D is congruent to angle H. So I have 4 pairs, oops, sorry, I went off the page, 4 pairs of corresponding congruent angles. So now I need to pick out the corresponding sides. And I'm going to use those markings to help me out with this. So I'm going to look here for AB between the right angle and this arc mark. So I know that side AB corresponds to EF. I know that BC corresponds, let's see, 1 arc to 2 arcs to FG. I know that DC corresponds to HG, and then DA corresponds to HE. Now, within any one of these segments, for example, if you called this BA and FE, that would be fine because they name the same segment. You just have to be careful that the correct segments are together. Now, since we worked so heavily with this in congruent triangles, I'm going to skip example 2 for right now. The only thing we would have to be careful of, these figures were oriented the same. Because these are not, it's going to be really important to match up those same markings together. But like I said, if we need to, we can revisit that in class tomorrow, but we'll skip it for right now. Okay, so here's where we're really getting to some of the work now. Now we're being asked to determine whether the polygons are similar, and if so, write a similarity ratio and a similarity statement. So when I approach a problem, I know in order to determine whether the polygons are similar, I need to check 2 things. I need to check that corresponding angles are congruent, and I need to check whether the corresponding sides are proportional. Unless I can say yes to both of those things, I don't have similar figures. So let's go ahead and check. We're going to check our corresponding angles. This one makes it really easy because I can see all my angles are marked congruent right in the diagram, so I can say yes. Now I have to do a little bit of work. I need to see if my corresponding sides are proportional. So in other words, I need to check is the ratio of WV to LM equal to VU over MN equal to XU over ON. And then I have to compare WX to LO. Again, just having one of these isn't enough. They all have to be proportional. So now we're going to plug in numbers. So WV is 25 over 15 for LM. VU is 15. MN is 9. Let's see, XU is 35. ON is 21. WX is 15, and then this is 9. So I'm going to use my calculator. These are pretty easy to reduce, but I'll use my calculator just to check. Let's see, I'm going to check my first ratio here. I have 25 over 15 gives me 5 over 3. 15 over 9 is 5 over 3. 35 over 21 is also 5 over 3, and 15 over 9 is also 5 over 3. All right, so I can say, really, I have all those ratios are the same. Once I've checked that, then I can say that, yes, my corresponding sides are proportional. So these are similar because I can say yes to both of those questions. Now remember, the similarity ratio is just the ratio between corresponding sides. So when we checked that, we actually found our similarity ratio, which was 5 over 3. Now for the last part is just a similarity statement. Again, the important thing here is that I have my corresponding vertices in the same order. So I would say WVUX is similar to LMNO. Now, where you start is not important. Just making sure that you have the same order is what's going to be important. So I could have said XUVW as long as then I said ONML, just to keep those corresponding sides in the same order. Okay, so for number 4, again, we're deciding whether the polygons are similar. We need to answer 2 questions. We need to know are corresponding angles congruent, and we need to know if corresponding sides are proportional. So if I look at this right away, it doesn't seem immediately obvious whether the corresponding angles are congruent, but since I'm told these are rectangles, I know that I have 4 right angles. So then I definitely have corresponding angles are congruent. So now I need to check my corresponding sides. So I only know the 2 lengths of 2 sides, so I'm going to compare PS to TW, and I want to know, is that equal to the ratio of PQ to TU? So let's see, PS is 4, TW is 6, and then I have PQ is 12, and this is 16. So let's check those out. So I've got 4 over 6, gives me a ratio of 2/3. Then 12 over 16 gives me a ratio of 3/4. Those are not equal. So since I kind of failed that second question, I know my figures are not similar. If they're not similar, then I have no similarity ratio and no similarity statement. Okay, so we're going to move on to the last page here. This one is going to go a little long, so I apologize for that, but please hang in there with me. Let's see, number 5, I think we'll go ahead. Actually, this will be a quick one. Okay, still the same directions. Our first question was whether or not they are similar. So, question 1, I need to answer, are the corresponding angles congruent? And question 2 was, are the corresponding sides proportional? All right, so I'm going to check my angles. So I notice here, Well, the first thing I noticed is I have a right angle here, and I have no right angle. There's no way this is going to be a right angle here. So right away, my corresponding angles are not congruent. As soon as I say no to one question, I don't even have to think about the sides because I need both to be true. So I can go ahead and say those are not similar, and again, that means no similarity ratio and no similarity statement. Okay. So now that we know how to tell or how to determine whether they are similar, we're going to use similarity to be able to allow us to solve for side lengths. So in number 6, we're being told that triangle RST is similar to triangle GHJ. And we need to solve for the value of x. So that x is right here. So we're going to use proportions to set up an equation that's going to allow us to solve for x. So the first thing I notice is if I have x, that's segment RT. And if I look in my triangle, I know RT corresponds, if I look at my statement, to GJ and my other triangle. And then to set up my proportion, I can use either other pair of corresponding sides. So I'm going to say RS, and I know that RS corresponds to GH. Now, that's less important using the similarity statement here because they're oriented the same way. When they're not oriented the same way, it's going to be more important. So now I'm going to plug in what I know. RT is x, GJ is 9, RS is 10, and GH is 15. So now we're going to cross multiply to be able to solve this simple proportion. So 15 times x is 15x. 9 times 10 is equal to 90. So if I divide by 15 on both sides, I get x is equal to 6. Okay, so again, just setting up basic proportions. Now, number 7 is the same type of problem. Here, our figures are just not oriented the same way. So again, we are trying to find, let's see, WV right here. I know that WV, let's see, if I look in my statement, WV here corresponds to HG. Now I need to find another pair of sides. The only one that I'm going to avoid is UV because I don't know that length. So I'm going to go ahead and pick WT. I know that WT corresponds to, let's see, HE. So WT corresponds to HE. And again, I'm using that similarity statement here because I don't have them oriented the same way. And again, just like before, I'm going to plug in what I know. So WV is 3x minus 1. HG is 7. WT is 20. And HE is 4. Now here, because I have this 3x minus 1, I have to be really careful when I cross multiply. So when I cross multiply, I'm going to get 4 times 3x minus 1. So I need parentheses there. 7 times 20 is going to be 140. Now, because I have those parentheses, I'm going to go ahead and distribute. So I get 12x minus 4 equals 140. I'm going to add 4 to both sides, so 12x is equal to 144. And when I divide, I get x is equal to 12. So now I have to be careful. They're not asking me for x here. They actually want to know the length of the side. So what I'm going to do is I'm going to plug x in here. So 3 times 12 gives me 36. Minus 1 is going to give me a length of 35 for that side. Okay, so that's how we use similarity to solve problems. All right, so now the last one is kind of using this similarity idea to solve some more application or word problems. So we'll do this one really quick. Again, I appreciate you hanging in with the longer video today. So here's what we have. The Willis Tower is 1,729 feet tall and 195 feet wide. Now, obviously we know it's not a rectangle, but I'm just going to kind of model it here with a really basic picture. So this is 1,729 for the height, and the base is 195. Now it says Mary bought a Lego set to build a model. Her model is 4 inches wide. So we've got a little model here. I should put this as feet, and this is inches. So it says find the height of Mary's model of the Willis Tower to the nearest tenth of an inch. So we're trying to find the height, which we're going to call x. And so the idea here is she's building a model, and we're assuming that model is going to be similar to the actual statue. So again, we're just going to set up our proportions. I know that 1729 is going to correspond to x on the model. Those are the heights. And then my base is going to correspond to the base on the model. Now recognize both of my units on top are feet. My units on the bottom are going to be inches. And then we're just going to cross multiply. So I get 195x equals, I'm going to go to my calculator for this, 4 times 1,729, and I get 6,916. Last thing I'm going to do is divide by 195, and I get 35.5 inches. Again, since this is the height of the model, that needs to be in inches, and we need to make sure we include our units. Okay, so that was kind of a lot for today, but we really needed to get the foundation of what similarity is. And so we'll do some practice tomorrow. We're getting close to the end here. So again, thanks for hanging in.